So Martin is the futurist for JISC, and he's going to talk to us about supercomputing in the cloud. So Martin, thank you.
Thank you very much, John. So I'm lucky enough to have futurist as my job title, but I think actually everybody here today in their own way is a little bit of a futurist. So whilst it might be my day job, I think we can all be futurists today. I wondered if anybody's seen this image before. Does this this is familiar? I know we won't probably all be able to hear you, but do you know what that is?
It looks like the graph of Facebook connections.
Very close. It's actually a graph that this guy did of research connections. So this is all about the research network equivalent of the Facebook social graph. And what's very clear there's that spot in the middle up towards the top there, which, depending on how flag waving you want to be, you could say Europe or you could say UK, and there's probably quite a bit of both in there. An awful lot of what we're talking about here today, really the research that uses the sorts of facilities that we're talking about today is interdisciplinary, it's international, it knows no boundaries, and I think this little plot that this guy did, which is based on trawling through several years of research papers and looking at the institutions for the collaborators, I think this demonstrates that global nature, that lack of borders, that lack of boundaries very nicely. And that's just my lead in. That's the warm-up, right? So I'm going to talk about three things, and I've got 20 minutes to do it in. I'm going to start off with a little bit of a look at reuse and reproducibility. So you might think, actually, are we going to talk about technologies of cloud computing? I'm going to touch on those a little bit, but what I think we often tend to do is we tend to leap into, and I'm a card-carrying nerd, so I do this as much as anybody. We tend to leap into, well, I've got shiny new technology, it's absolutely brilliant, so you should want to use it. And I think it's really worthwhile just taking a step back from that to say, well, actually, what real problems are we trying to solve? So a little bit on that, and then a little bit about how cloud computing technologies can help with that. And I apologize, I wasn't here earlier on, so if I retread some ground that you've already covered, do feel free to just sort of go, you know, we've heard this, you don't need to repeat it. And then I'm going to leave you with what I would call a provocation, really, which is where can we go with what we know now, what we're now becoming able to do, that perhaps some of these things are things that we've been able to do to an extent in the past, but now all of a sudden a whole bunch of things are really coming together. So that's my parting shot. I have to do the kind of contractual obligation, well, who the heck are you and where are you from? So I work for JISC, and you might have come across us, you might not. If you haven't come across us, you probably use our stuff every day. So we run the Janet network, which we reckon has about 18 million users, mostly in the UK. And we also operate Eduroam in the UK. So whenever you connect to Eduroam, if it works, go, woo, yay, JISC. And if it doesn't work, come and find me afterwards and tell me what went wrong. Behind the scenes, we're trying to figure out all the time what we could do next, for research, education, and for the skills sector. And that's what being a futurist at JISC actually means. I'm there trying to sort of poke and prod and look out for things that we could be doing. Who could we be working with to help bring those things to fruition? So that's me. What about this reuse and reproducibility then? Has anybody seen this article in The New Yorker before? This is a few years old now. So this is the article that broke, really in a public sense, in a mainstream sense, something that I guess we could call the reproducibility crisis. So if you're a researcher, if you're actively trying to reproduce the results of other people's research, other people's studies, other people's experiments, you probably have quite a deep understanding of this already. But for most people, you see a scientific study indicates that. So, right, okay, I'll wait for the rebuttal a couple of days later. You know, if it's the Daily Mail, I've read that water causes cancer, and then a couple of days later they'll be saying, oh no, actually water's the best thing ever. What the New Yorker broke there really was the story that experiments are hard to reproduce. So I think I can see a few researchers in the audience, and you'll be saying, well, you know, okay, maybe, maybe not. Let's drill down a little bit more. Here's this paper in Nature where 1,500 scientists were surveyed, and they said, actually, okay, this isn't universally true. It's not universally true, but there is a lot of research which is hard to reproduce. And if it's hard to reproduce, then you end up repeating it. I couldn't do this. I couldn't satisfy myself that this stuff that this person has discovered over here is just a given. I'm not completely happy about it, so I end up doing it again. Maybe I end up doing it again. Maybe I'm just not really certain that the underlying research that I wanted to build on is built on a solid foundation. And the paper in Nature has this nice breakdown by subject domain. So if you're an engineer, for example, and what's that top left one? If you're a chemist, any chemists or engineers in the audience today, you can put your hands up. So for you, the reproducibility problem may be not such a big deal. If you're in medicine, of those 1,500 respondents, quite a lot of them said, well, there's a lot of uncertainty here, not completely happy with all these results that we're seeing. And obviously in medicine particularly, there's also the issue of the reporting of negative trials, which Ben Goldacre has done quite a lot of work on trying to turn around. But these questions, these things, ultimately, they're the underpinnings of the next wave of research, the next wave of discoveries. And if we can't reproduce them, and if we can't be confident about reusing the results of that previous wave, then that really ought to cause us some problems. What's very nice, of course, is that the community has come together. I mean, I said that New Yorker article, that's, I think, 6 years old now. So obviously the community has started to come together to say, what can we do about this? What can we do about this in particular subject domains, in particular disciplines? So I've picked out this particular science exchange example because they are very actively trying to do this around major projects. Now let's say we can give this project a kite mark, a gold stamp of reproducibility. And this might all seem irrelevant if you came here principally to hear about HPC, to hear about cloud computing, to hear about OpenStack. So what I wanted to do next, really, is to try and draw those strands together a little bit. And there's a particular thing that's happened over the last few years, which is that research funders have said, and it's quite important, as well as making your publications open access, it's quite important that the data gets out there too. If the data gets out there, people can attempt to reproduce your stuff perhaps just that little bit more easily. They can have greater confidence that the data that your publications are founded on is of a high standard, is reliable, and is, you know, these things are repeatable. So Research Councils UK came up with their data policy principles, and it's nice to see Susan from EPSRC here today. EPSRC I would say put a rocket up a lot of people's backsides, actually, by saying, well, we'll put a date on it. We expect you to start sharing your data. And that's galvanized a lot of activity and a lot of energy. And just this year, just this summer, we kind of saw the next stage in that, which is this concordat on open research data. I should say, by the way, we've got some links to these things in the slides. So afterwards, I think we'll be sharing the slides. So do feel free to follow the links if you're interested when you get the slides later on. Don't feel that you have to kind of peer at them to work out what the URLs say. So the concordat on open research data, that's really a landmark thing. Joe Johnson, in his foreword to this, says, and I quote, And for the first time, we propose a series of clear and practical principles for working with research data. It's not a rule book, a set of expectations developed by the research community itself. So this is the minister who ultimately the source of funding for all of this stuff that we're doing in the research sector, saying get on with it, basically. We've been doing a little bit ourselves, so again I have to blow our own trumpet a little bit. This is something that we've been building which we call Research Data Discovery Service. So a whole load of institutions and research institutes have said, right, okay, we need to start sharing our research data as a matter of course. We're starting to look at how we do that. This is a little site which picks up the metadata, if you like, the catalogue entry for the data that you're sharing about your research project. And it makes it searchable, it makes it browsable, and not wholly convinced about the map, but if there's a geographical element to it, well, I know it was a Scottish university. I know it was somewhere in the Midlands. Maybe that would be useful too. So that right now, that's an old screenshot. That's got about 16,000 data sets in it right now. We do a similar thing for librarians, which tries to aggregate open access publications. So we see that open access to research, publications and the data is really a key thing going forward. We're also building a research data shared service. So again, a lot of the people that we talk to say, yeah, we completely agree with this. This is absolutely what the UK should be doing. A little bit of a problem actually getting galvanized, getting to the point where we can action, setting up our own research data facility. That's a hard thing. If you're a research-intensive university like Birmingham, and say, well, we are going to put a significant amount of resource into this, we will have this, we will do this, it's a strategic priority. If your research intensiveness perhaps is a little lower up on the scale, this is actually a hard thing perhaps to justify resources for. So we think that the shared service, we already have over a dozen institutions who are interested in piloting this. Do talk to me if this is something you're interested in. We think that there's got a lot of mileage. We think this will help, and it will help to feed the other thing. So there's a sort of serendipity to it. That's enough of the plug. So cloud is really what we're here to talk about today. What actually does cloud do to help with reuse and reproducibility? I'm not sure, maybe, I know this is a Red Hat diagram I'm using here. Maybe we should have a Lenovo version. The OpenStack technology that we're talking about here with Bear Cloud has a number of bits. And the bit that I'm going to suggest that's particularly interesting for reuse and reproducibility is the bit that drives the compute over on the left-hand side at the bottom, the bit that drives the Nova compute engine. So what's the point of that? Well, the point is virtual machines. Once upon a time, if I was a researcher, I would build up, perhaps on an HPC cluster, perhaps on a workstation under my desk, I would build up the software stack, the pipelines that I needed to process the data that my lab's instruments generated or the samples that came back if I'm doing biobanking or something like that. Nowadays, if I'm running that on a virtual machine, if I'm running it on a virtual computer, that can be snapshotted. We can take a picture of exactly how that computer looked at any point in time. So as the researcher, I'm building that environment up, and that is what produced the results that I write about in my publications. So the very, very powerful concept, and I think if your head is buried in the guts of the machine, as mine was until quite recently, this is very hard to fully appreciate the significance of. The idea that we can have a snapshot at a moment in time, and then we can say, okay, who else wants this? This is my machine for processing gene sequencing data, particle physics and astronomy data. Let's say it's the feed from the Large Hadron Collider. This is my machine for doing it, and you can have a copy of it. And that is a really, really huge thing. And we've been able to do that before. There's nothing vastly new about this. What is new, I think, is that it is reaching more people. So in the past, this would be something that you could do if you were one of the cognoscenti. And I think what a system like Bear Cloud gives us is it democratizes that process. So it democratizes the process of taking that snapshot that you can share with people, and it also gives it to you in a form that has a team supporting it. So it's not just you. If you're the researcher, you don't have to sit there and go, how do I put all these bits together? I've read from other people about how they've combined these pieces of software. A good example here is something called Galaxy in the bioinformatics space, which is something like 50 or 60 different packages which have to work together. You've got your work cut out for you if you want to produce that yourself. It's much easier if you can just tap into something that someone else has done. So virtual machines. And let's just say as well, OpenStack is open source. And in the past, we might have said, open source technology, essentially free software where the code itself is given away. Can we trust that? That sounds a little bit like something that a bunch of hippies would do. They're just writing stuff and they're just giving it away. So what was very telling for me was when, a couple of years ago, CERN decided that OpenStack was good enough that they would run the whole of their compute on it. So this is a pretty big endorsement, so that all of that data flowing through the Large Hadron Collider coming out through an OpenStack cluster for processing. And let's remind ourselves here, what was the number there? It's as though we had 100 megapixel digital cameras the size of the Notre Dame Cathedral spitting out data every second. So it's quite a lot of data coming out of the LHC. It's a real vote of confidence in this OpenStack architecture. And I think that's one of the particular reasons that we've seen it becoming quite widely adopted for scientific computing. CERN proved that it could be done. If we look a little bit further afield, both Microsoft here with their VM Depot, as they called it, this has been superseded now, and this has been rolled into their public cloud offering Azure. And Amazon with their AWS Marketplace, what they've said is, we know that there's a lot of interest in this. We know that it will help people to get up and running if they can just go out and they can find that virtual computer image, the virtual machine image, that has that particular combination of software, those versions of those libraries and all of the dependencies that the software needs to run on tap. So this is a very nice place to be. It's quite new, I would say still, for scientific computing. And it's very telling, these public cloud providers, they've been doing this for a while. You go out there and you look for CRM systems, customer relationship management. You look for WordPress, web publishing environments. You look for things like this. They're all out there. They're all over the place. Much less for scientific applications. So I think that there's a little way to go there. And that's why I say I think that although these technologies have been around for a while, we're still really in our infancy of seeing what people will do with them. There's also, coming along, is something called Docker. And Docker is very interesting to me because it takes away a lot of the fiddling around to create the machine that the stuff runs on. We don't really have time today to talk about why Docker is a great thing. But I think that you'll be seeing a lot more of Docker and the container technology that it's based on, which is a simpler way of doing these virtual computers. Simpler, and it performs almost as well as if you didn't have any of this stuff in the way in the first place, which is the green and the blue bars in that diagram. Also, it's got an awful lot of interest. So anything that has that many different vendors interested in it, we probably want to sit up and take notice. What I really wanted to finish on, though, was this question, what's our new paradigm? If we say that now it's suddenly these technologies which have been the preserve of the hardcore computer scientist, networking and infrastructure nerd are now being democratized so that ordinary researchers can get access to them. what actually does that mean for us? And where does that sit in relation to, let's call it open science more broadly? So in the last couple of years, we've seen an explosion of interest in research identifiers for people. So, you move from institution to institution. I'm not interested in the institution, actually. I'm interested in your research. An ORCID ID is a unique ID for you as a researcher. So there's been a whole load of interest in that. DOIs, digital object identifiers, give you a reference to an object, a publication, let's say, or a data set, which is independent of the website it's hosted on. And that is huge. If you think about the number of websites that had stuff on them which is referred to in scientific papers that are just gone. So in the past, you would have said, oh, I'll just go and take a look at that. Last week, I could have gone and taken a look at that link. Today, it's gone. So DOIs give you a way of referring to things which is independent of where they actually live on the web. In the world I move in, we're also trying to build we saw the Research Data Discovery Service, we're also building an equipment database that sits alongside it. So, actually, I don't just need a mass spectrometer, I need this model of mass spectrometer and I need it running this version of the firmware. And only then do I have the complete environment that I need to reproduce my research. So there's a few of these sorts of things. And I would like to think, and this is my conjecture to you, my provocation, if you like, I would like to think that if we put our minds to it, we can really move beyond swapping PDFs as the unit of research output. Some of you may know there's been a conference running for a few years now trying to get to the bottom of exactly what would that next generation research output look like. But let's just imagine figures, tables, data, software, all of these things individually citable, individually reproducible, as their own first-class items, their own unique and special and distinct things. So I think that where cloud and where systems like Bear Cloud sit actually right in the middle of all of this as really key enabling technology. And you can see a little bit from the Research Object project, which actually those guys are trying to design what that new research infrastructure might look like. So do go and take a look at that. What's most important, though, and my parting shot for you, is I think the absolutely critical thing is to have a team of friendly experts that you can tap into so that you don't have to go away and learn all this stuff. And that's probably my cue to say over to John. Thank you.
Thank you very much. You might think that we collaborated on some of those points. But, that was great. Thank you very much. Maybe just one question. I know we've got quite a packed agenda, but is it just one point? Okay. I mean, I think just an observation from me. I think, yes, it's so important, and we're not only saving the data, we have to reproduce that machine to rerun the data and the software. So, well, thank you very much.
I just found the trapdoor as well.
Yeah.
I mean, I didn't stand on that.
Thank you.
Thank you.